G'day everyone, how are you going? Today's video on quadratic formula is this ability to take this equation here, which is our general form of a quadratic equation, and actually turn that into the quadratic equation. You might have seen this, you might have used it, but you might not know where it comes from. Will you ever really be asked to do that? Well, in the methods course that I teach in Year 11 in WA, no. You want to be able to use this, but the derivation of it or how you get it, you wouldn't be asked that in a test. And in reality, we're going to take most of the board here to actually get to it, so it'd have to be an 8 or a 10 mark question. We wouldn't do it. So nice to see this video through to how we get here, but will you need to know? No. Make sure you can use this. You know what the discriminant is telling you, you know what the line of symmetry is telling you, you know how to get your x-intercepts, and that'll be fine. So let's start. We start with our general format here. So we need to move that into this format. The way we do it is by completing the square with the A, B and the C in there. So essentially what that means is we're going to have a whole lot of algebra on the way through with no numbers. But that's okay because there's no numbers apart from a 4 here. There's no real numbers and a 2 in the final product. What are we going to do here? Well, if I want to complete the square, my first step is going to say, well, I just want to take this part here. So I'm just going to take the ax squared plus bx, and the c, if I was completing the square, I'd move that well out over here. Now from this section here, what I think is this a value is going to cause me a bit of trouble. Normally when I complete the square, I just have an x squared there, not an ax squared, so a coefficient out the front. So what I'm going to do is actually rewrite this. I'm going to take a out the front of this part just at the beginning. I'm going to take an a out front of x squared. Now if I take an a out of here, that's fine. But if I take an a out of here, I've really got to say this is now b over a lots of x. Think about this, multiply the a in, the a top and bottom would cancel, leaving you just bx, I'd be back to the original. So this is now in a better format for completing the square. Now if you remember with completing a square, we halve this value here, the value with the x term, halve it and square it. Add it on, do the same and take it off. So half of this value is going to be b over 2a, and we've got to square that, b over 2a squared. I'm adding that on, just move this over a bit, and then I've got to take away b over 2a squared. So these two cancel each other. Now that c that I've put out the end there, I've got to recognise that's going to be outside of this bracket that I've created. Because remember, I didn't take a factor of a out of the c like I did with the b, so I just left that right at the end. So really, this part here is all replicated into here, because if these two cancel each other out, and then if I was to multiply the a in, I'd get back to this here. So this here is not changed one little bit. Looks different, not changed one little bit. Let's just work within here now. I'm going to take this guy and I'm going to move him outside of the brackets, because I really only want this part here to complete the square. That's my complete square. So let's move him outside the bracket. So it's going to be a bracket x squared plus b over a lots of x plus, now you can leave this as it is, b squared, b over 2a all squared. Don't multiply it out. Now what I'm going to find is I've got a lots of this one, because I want to move him outside the brackets. So that's going to become minus a, careful of your brackets here, b over 2a squared, because that's that a, this one really, being multiplied to here, and then I move him outside the bracket, plus my c. Okay, let's keep tidying up. This section here is now a perfect square. Okay? So I can write a brackets x plus b over 2a squared. Hopefully you can see that. That's just completing the square, and that's the whole reason I did the add subtract up here. And out here, I'm going to tidy this up now. I am going to expand this bracket here. You should see I can get a b squared over, squaring this will get me 4a squared, and my plus c at the end. Now that's neat because this a and the square part of the a is going to cancel. So I've got b squared over 4a plus c. want to do a little bit of work with this guy, so I'll leave this a part here, x plus b over 2a squared, leave him the same. This I want to put on a common denominator. Right? Now, because I've got a negative here, I've got to be a little bit careful of that one. So negative b squared over 4a, and this I'm going to put on a common denominator, so I'm going to go plus 4ac over 4a. And hopefully you can see here that the 4a and the 4a will cancel, bringing me back to here. So that would mean, I'm going to rub this out, that would mean this part here I could put on the same denominator, okay, on the same denominator, but be careful of the negative here, right? Be careful of that negative. Actually, I'll write it separately, then we can see it. X plus b over 2a squared. Now, I'm going to go, leave that minus for a moment, I'm going to go all over 4a, because that's the common denominator here. I'm going to put b squared, for the moment I'll put plus 4ac. Now if I was to put a negative here, can you see how that would be negative b squared and negative 4ac? So I've actually got to change that one to a negative, because if I was to multiply this in, I've got to get back to a positive here. So that's a step that sometimes gets mistaken. So I'm kind of looking okay now. I think I'm okay. Well, not really, but this is completed the square. This would be telling you your shift left and right. This would be telling you your shift up and down for the turning point, and A would be the shape of the graph. So hopefully you can still see all of those things in there, even though they're letters and not numbers. Now if I did this, completing the square, and then I wanted to find where my x-intercepts are, wouldn't I, let me just bring my y all the way down, wouldn't I be letting y equal 0? That's when it crosses over the x-axis. So I'm going to let y equal 0 here. So I'm going to have 0 equals all of this, a brackets x plus b over 2a squared minus all this whole thing here, b squared minus 4ac all over 4a. Looks a bit crazy at the moment, but that's all right. So if this is 0, let me move this whole term over to the other side. So it's going to be positive now, b squared minus 4ac all over 4a equals a brackets x plus b over 2a squared. Now this a here, I want to get rid of that one. So if I divide this side by a, I've got to also divide this side by a. So that would mean that I'll end up with now b squared minus 4ac all over 4a squared. That's going to be kind of handy to me, I think, equals x plus b over 2a squared. Now the whole purpose around here and what I'm doing is obviously letting it equal 0 to find my x-intercepts. So I'm trying to isolate this term here. That's my x term. That's the thing that I really want to get x equals, because remember, way over here, this is where we want to get to. So I've got to get x equals out of it. Okay, where am I going with this? Well, I've got a squared here, so I've got to get rid of that. So I've got to take the square root of this side here. So I'll do this in the same step. So I'll put a big square root here. And when I put the square root here, isn't this square and square root going to cancel out? But here's the careful thing we've got to do. Taking the square root of something, we end up with a positive and a negative answer. So whether I put the positive and negative here or here doesn't really matter, but I'm going to put it over here. I'm going to put the plus and minus over there, because we'll definitely get two answers. So the square root of 16, for instance, is plus and minus 4, not just 4. Okay. So this square root and square root here is gone, but I've got one over here. Now you remember I said this is handy here. I've got 4a squared. Well, I think I can do something with that, because isn't the square root of 4a squared just 2a? That makes sense, doesn't it? So I'm going to rearrange this to plus and minus. The square root's now just going to be on the top line, and on the bottom line I'm just going to have 2a, because 2a is, if I work that into something, the square root of something, it's got to be the square root of 4a squared. So that's actually exactly the same here. And on the right hand side I'm going to have x plus b over 2a. It's kind of falling out now for me, because if I just move this b over 2a over to the other side, it'll become negative. So I'll actually write it in terms of x equals. Now if I pick this up, the b over 2a, move it over here, it becomes negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, and this bit's kind of handy. So that means I'll end up with x equals minus b, putting it on a common denominator, plus or minus b squared minus 4ac all over 2a. And if we check back up over here, we notice we've made it. We've got all the way there. So quick summary, completing the square, be careful about things you move in and out of the brackets, setting things up on a common denominator on this second part, completing the square on the first part. We get to here. We've then got to let y equal 0 because that'll give us our x-intercepts. So we start to tidy a few things up, move it over, square root of both sides cancels a little bit here. This changes here into a 2a, which is neat. Remember the plus and minus, taking the square root, got to have a plus and a minus. I'm left with this, the b over 2a moves over, becomes negative, common denominator, and there we go. It's all fallen out for me pretty neatly. And there you go for the quadratic equation from the general form of a quadratic. Hopefully you never get this in a test question, but if you do, you've seen it all the way through. Thanks very much. See you later.